Hello everyone, welcome back to our Lee County Library Science Club. It's great to have you with us once again. Just a reminder, please make sure you have your parents' permission and some supervision when you're doing these experiments with us, alright? Over the course of these videos, we have shown you concepts from all different branches of science. And one of the ones we've talked about a lot is physics. Physics, technically, is the study of force, energy, and motion. We learn about things like gravity, momentum, acceleration, and all the other different ways that matter interacts with each other. But when you actually study physics, there is one concept that without it, none of the other ones would actually apply to our real world. And that concept is friction. Friction is the resistance that one surface encounters when moving across another. And like I said, without friction, well, the world that physics would create, we wouldn't actually be able to live in. Okay? Because things like force. If I push against the floor with my foot so that I can walk, okay, I'm applying a force and it's creating acceleration to move my body. But if there wasn't any friction, well, I would push against this floor and my foot would just fly out, wouldn't it? Yeah, like walking on ice. Have any of you ever gone ice skating or maybe on some frozen water in a parking lot or something? It can be really hard to keep your balance and move, right? Well, without friction, our entire world would be that way. I'd push on this notebook, and the force and acceleration I have given it, it would just keep going. It would fly right off the table and keep sliding along the floor. But because of friction, it only travels about a foot or so. There are three main causes of friction. Those are adhesion, roughness of surfaces, and deformation. Now, adhesion we've talked about a little bit when we were talking about water. That is the electromagnetic and molecular forces that cause molecules from different materials to be attracted to each other. Now what that means is, as I'm moving this notebook across the table, there are millions of molecules on the surface of the notebook and on the table. And as they pass by each other, those molecules may be attracted to each other, and they pull against each other, causing some resistance. And this may be caused, like when we talked about the water, by polar molecules having that slight electric charge, causing them to pull on each other. But there are some other more complicated molecular forces that also can cause that pull, that attraction between the molecules. Now the second cause I said was rough surfaces. But some of you probably say, this is a pretty smooth table, right? And if you took a piece of paper and you run your hand across it, it feels really smooth, doesn't it? But if you took a microscope and looked really closely at this paper, you would see that it's actually full of hills and valleys and little holes. And when these surfaces move against each other, those hills and valleys run into each other and catch, and again, cause resistance, creating friction. The last cause can be deformation, which if a material is soft enough, or if you are pushing hard enough, when you push on it, it might cause it to change shape. Right? Like I can hold this paper up and push, and it might change its shape as I push on it. Well, if I'm pushing it across this table, then that slight deformation means the force I'm applying is being used to change the shape of the paper rather than causing it to move. And that wastes some of that energy and again causes friction. Now, friction is very strongly related to Newton's third law of motion, which is every action has an equal and opposite reaction. For instance, if I push on this paper again, well, I gave it a certain amount of force to get it to move. which means in order to make it stop, friction had to apply an equal amount of force in the other direction, right? So when I'm walking, I'm pushing backwards against the floor. And in order for my foot to stay in place, the floor and the friction between the foot and the floor needs to apply the same amount of force against my foot. Right? So that is one of the fundamental concepts of friction, is that it is an equal and opposite reaction to a force that you apply on an object. The amount of friction that gets applied to an object and how quickly that object will slow down or use up the force that you've applied to it is directly related to how much surface area an object has. For instance, this piece of notebook, if I put it on the table, there's a lot of surface on this side. So if I put that side on the table and push it, there's a lot of friction being generated. However, if I took this same piece of notebook and turned it, put this edge on the table, see, this is a much smaller edge, so there's a lot less surface area. And if I put that on the table and move it, well, there's a lot less friction there. And actually, for me, it feels smoother when I push it across the table. And if I could make this stay upright when I pushed it, it takes it longer to slow down and stop than when it's on the large surface. Okay? So remember, that's a big concept here. The amount of surface area directly relates to how much friction is created between those two surfaces. Our experiment today is going to show how that works. Now, it's a very simple, easy experiment. All you need is 2 books, or 2 notebooks, or a couple stacks of paper, if that's all that you have. So let's see what happens. So we're going to start with our 2 notebooks sitting right next to each other. Okay? And I've got the open sides of the notebook facing each other. So we're going to do this experiment in different stages, but in each one we're going to take a certain number of pages and overlap them from the 2 notebooks and then try to pull them apart. For the first one, I'm just going to take one notebook, put it on top of the other one, and then pull them apart. And it's pretty easy, right? Like, there's almost no resistance at all. And that's because there's only the surface area of this one side against this one side. And it really easily just pulls apart. So now, let's do it in half. I'm going to open this one halfway, and I'm going to open this one halfway. Alright? So I'll put this on here, and then kind of twine them together, and there. So now we have 1, 2, 3, 4 different surfaces all together. So we actually have 4 times the amount of surface area than we had in our last one. Now, let's try again to pull them apart. Alright, it's still pretty easy, right? It took a little bit more effort that time, but it's still not too hard to do that. So, let's try in thirds this time. Alright, I'm going to come open this up about 1/3 of the way, and this one about 1/3 of the way. Again, I'm going to lay it on top, and then I'm going to take what's left, take about half of what's left, and fold it back on the other one. And again, take about half of what's left, and then fold the last ones on top. So now, we've added several more layers and a lot more surface area. Now let's try again to pull it apart. Alright, that one definitely took a lot more force that time. I don't know if you could tell, but it kind of got stuck right at the beginning. It took a good yank to get them apart. All of those are cool, But the really cool part is what happens when we combine every single page. Alright, so I'm going to go ahead and intertwine this page by page, and we're going to see how hard it is to pull these books apart. Here we go. Okay, we've finally got them all woven together. Now, the big test. Let's see. Can we... See that? I can't even pull them apart at all. Can you do it? Whew. I don't know, I can't get it. Why don't you try, have your dad do it, see if he can pull them apart. Maybe try, you grab one end, and you can have a friend grab the other end, and you can see, and try whatever you can to try to pull them apart. Chances are you won't be able to do it, and that is because we have created so much more surface area. In fact, these are about 100-page notebooks, which means we have 100 times the amount of surface area, actually about 200 times the amount of surface area than we had when they were just together. And that means we have almost 200 times the amount of friction between these notebooks than when they were just laying on top of each other. And that is just so much, it's almost impossible for any of us to be able to pull them apart. So as you can see, friction can be one of the most powerful forces in our entire world. And like I said earlier, without it, we wouldn't even be able to live here. It is that important. Thank you so much for watching. We'll see you again next time. Bye.